these orbital shapes the letters S, P, D, and F, and they all correspond to the shape of the actual atomic orbital. The S orbital is spherical in shape, so I remember S for spherical. The S orbital is like a sphere. Now these are three-dimensional. The P orbital is sort of shaped like a peanut. So I remember peanut shaped. P for peanut. The D orbital is sort of like having two of your P orbitals. So I call this a double peanut. This will be one of your peanuts, and this will be the other peanut. That's your D orbital, D for double peanut. And the F orbital, I remember F for flower. The flower shape is really like having three of your D orbitals together. There's one D orbital. This will be the second D orbital. And then your third D orbital will be sort of coming out at you three-dimensionally. So I call it a flower shape. So F for flower shape. Those are the four atomic orbital shapes. And as I was saying, this is sort of like the houses that they live in, what their house will look like. Some people live in really simple, small houses, like some electrons live in very simple, spherical-shaped houses. And then you have some people that have really elaborate, fancy houses. So that would be like your F orbital here that we see. Now, we use quantum numbers to represent the location of the electron. It just so happens that this location requires 4 quantum numbers. Each quantum number gives us a little different piece of information about the electron. So just like you have an address, if I wanted to send a letter to your house, I would need to know your street that you live on. I would need to know the mailbox number. It would be helpful to know a description of your house. And then I would need to know your name. And in our analogy that I'm going to use, every house only has 2 electrons that live in it. So every house has, think of it as like they have 2 people that live in them. And in our little electron city deal that we're learning about, the electrons that live in the houses, one has to be the female and one has to be the male. And that's important for later on when we talk about the spin quantum number. The first quantum number is called the principal quantum number. It is your very first quantum number. The principal means first. I always think of this, help me remember this, I think about the principal at the school. He's like the leader of the school. This is your lead quantum number, and we represent the principal quantum number with an N. N is equal to the energy level that you will find the electron in. Now, when you look at the periodic table, we learned there are 7 periods on the periodic table. There are 7 energy levels within the atom. So the energy level quantum number describes which energy level you find the electron in. It's sort of like the street that the electron lives on, if you want to think about relating it to your address. It's like the street that he lives on. What this tells us is the amount of energy that the electron has. N can have values equaling 1, 2, 3, 4, 5, 6, or 7, just like the period on the periodic table. The N quantum number always corresponds to the period number on the periodic table. So it's very easy to find if you have a periodic table in front of you. One thing you notice in your atom is your energy levels This represents your nucleus, and if you have your energy levels surrounding your nucleus, I can't get 7 energy levels here in my space that I have, but you will notice that as I keep adding energy levels, as we talked about when we talked about sizes of atoms, this will be equal to n equals to 1. First energy level, this is n equals 2, 3, 4. And it would continue on until you get to n equals 7, the 7th energy level. So as n increases, you're getting farther and farther from your nucleus. So as n increases, the distance from the nucleus also increases. The second quantum number is called your orbital quantum number, and it's given a letter L. And it's always a cursive L. I remember L, and it's called orbital quantum number. And orbital ends in an L. That's how I remember L. Let me go back for just a moment and talk about how I remember N. I remember N is the letter for the principal quantum number because it tells me the energy level. So N and energy level. That's what it tells me. Hopefully that'll help you remember the specific piece of information that each of these quantum numbers tells us. L is your orbital quantum number, and it tells you the orbital shape. So when I showed you the orbital shapes a few minutes ago, S, P, D, and F, that's what L is describing, the shape of the orbital. So the value of L indicates a specific shape. L can have values equaling from 0 and then going all the way up to n minus 1. So L does depend on what n, the principal quantum number, is equal to. So if L equals to 0, that means you're describing an s orbital. The way I remember that is if you were to have a sphere and you trace a sphere, you would get a 0. Okay? So if you were to trace a sphere, it looks like a 0. All right? If you have a p orbital, remember we said the p orbital looks like a peanut, L is always going to equal to 1. If you have a d orbital, remember the d orbital, I said think about a double peanut. So you have 1, 2 peanuts here. So L is equal to 2. Okay? Because I got 2 peanuts. That's how you can remember it. L is 1 because I have 1 peanut. Again, these are just little ways that I remember it that I'm sharing with you. If L is equal to 3, that's describing a flower-shaped orbital, your F orbital. Remember, your flower-shaped orbital is like having 3 of your peanuts together. So 1, 2, and then 3. So 1, 2, 3. L equals to 3. Your L quantum number describes the shape of the orbital. Whatever L equals to corresponds to a specific shape. The third quantum number is called the magnetic quantum number. It's given the symbol or letter M for magnetic. I remember M and magnetic starts with an M. What this quantum number tells us is how the electron cloud or how the orbital is oriented in space, how it's positioned in a 3-dimensional space. The values for M will range from negative L to positive L. So just like N determines what L can equal, M, the magnetic quantum number, is dependent upon the L value. It can go from negative L to positive L. So one thing you want to remember about each orbital type, the S, the P,